Okay, so now we're going to take a look at when you would use the sine law. There are two situations where you would want to use it. One is when you are given two angles and one opposing side. Oops. And the second situation is when you are given two sides and one opposing angle. Okay, and I'm going to use congruency conditions to show that. Okay, and what we mean by congruency conditions is that our triangles are uniquely defined. Okay, so it means that the triangles are uniquely defined. Okay, so that means that if I have this information that's given to me, then if I were to draw another triangle with exactly the same information, they would both have the same angles and the same sides, and therefore have the same shape and the same size. Okay, so the first situation is where I would have an angle, angle, side. So A stands for angle, S for side. So the information that's given to me in this order: angle, angle, side, or side, angle, angle. Okay, whether I read it forwards or backwards doesn't matter. Okay, so I would go from an angle measurement that I'm given to an angle measurement that I'm given to a side that I'm given. So angle, angle, side, or if I like, side, angle, angle. Okay, so if I were to draw a second triangle with exactly that same information, these two triangles would have the same shape and the same size. Okay, now in terms of the sine law, it's really important that you have a given side opposite a given angle. Okay, so if you have that situation, then you could use the sine law. Now if you take a look at the second diagram here, we have an angle, side, angle. So we have a given angle, a given side, and a given angle. And remember, it doesn't really matter which order I read it in, so angle, side, angle. But on this one here, I have a side of 6, but I don't have an opposing angle. But because I already know two angles in this triangle, I can easily work this one out, right? So I could just go 180 minus 80 minus 30, because I know all angles in a triangle add up to 180. And when I go 180 minus 80 minus 30, I would get 70 degrees, so I would know that this triangle, or sorry, this angle here is 70 degrees. And so now I have a side opposite an angle, or an angle opposite a side. Now, if I were to draw a second triangle with exactly the same information, I would get exactly the same triangle. They would both be the same size and the same shape. Okay, and just this chart, for some reason my 2 is lost here, so you can put 2 here for two angles that are given. Okay, now our second situation, we are given two sides and one opposing angle. So what's important here is that your angle that you're given is not contained. In other words, the angle that you are given is not between the two sides that you already know. Okay, so how you would read this, you would go side, side, angle. If you want, you can go the other way around, angle, side, side. But what's important here is that a side-side angle is not a unique situation. Okay, it can be, but at the same time, it might not be. Okay, so in this situation, you may or may not have a unique triangle. Okay, so what does that mean? That means that you can still use the sine law because you have an angle opposite a given side, so you can still use it, but you may not get a unique triangle. You may have to check to see if there is another triangle that's possible in the same situation. Okay, so they won't be unique. So we call this the ambiguous case. Okay, so in the next couple of videos, we'll take a look at how we can use the sine law.